Have you ever stopped to think about what's running in the background of, well, everything? From your Google searches to the very laws of physics? Turns out there's a kind of secret language, a code that underpins it all. And today, we're going to break down its three most fundamental building blocks: sets, relations, and functions. The great mathematician G.H. Hardy put it perfectly. He called math the oldest and the youngest study. It's this timeless language of patterns that's been evolving for thousands of years. And you know what? We're about to learn its basic alphabet right now. So that leads us to the big question, right? If math is a language, what are its ABCs? What are the simple, super core ideas that everything else, and I mean everything, is built on? Well, the answer is actually pretty straightforward. Let's dive in. Our very first building block, the absolute ground floor of it all, is the idea of a set. Think of this as the A, B, and C of the entire mathematical world. So, what on earth is a set? It's just a collection of things, but with one absolutely critical rule. It has to be well-defined. That just means there's zero room for ambiguity. For instance, the list of players on the Indian cricket team is a perfect set. You're either on the team or you're not. Simple. There's no debate about it. And this is where that well-defined idea really clicks. Look at the left. A set of the rivers of India. That's a fact. The Ganga is in, the Nile is out. But on the right, the most talented writers? See the problem? Who decides what talented means? It's totally subjective, it's an opinion, and opinions can't form a mathematically sound set. Now, there are basically two ways you can write down a set. You can use what's called the roster form, which is kind of like a roll call. You just list every single member. Or you can use the set builder form, where you just state the rule that all the members follow. As you can see right here, they both describe the exact same set of vowels, just in different styles. Okay, so we've got our alphabet, our sets. What's the next logical step? Well, we start putting those letters together to make connections, to form mathematical words. And that journey begins by mapping out every single possible connection you could imagine. This first step involves something called the Cartesian product. It sounds complicated, but all it is a master list of every single possible pairing between two sets. It's the universe of all potential connections we could possibly make, the whole shebang. Let's make this real with a simple menu. Imagine set A has our breads, roti and naan, and set B has our curries, paneer and dal. The Cartesian product is literally every meal combo the restaurant could offer. In this case, that gives us 4 potential pairings. But let's be honest, a restaurant doesn't usually offer every single random combination. They create a specific menu, right? And that's exactly what a relation is. It's a meaningful subset picked from all those possibilities. It's not about everything that could be connected. It's about the specific connections that actually matter. So if that Cartesian product was all 4 possible pairings, our Thali combo relation is just this specific menu of 2 choices. It takes the chaos of all possibilities and gives it some order, some purpose. All right, now we get to the real hero of the story, a function. This is a special, super reliable type of relation. It's a relation with one very important, unbreakable rule that makes it one of the most powerful tools in all of science and math. So a function lives by 2 golden rules. First, every single input has to have an output. No one gets left behind. And second, and this is the big one, every input connects to one and only one output. Not 0, not 2, exactly 1. This strictness is what makes functions so incredibly predictable and powerful. And this rule is so critical in the real world. Just think about booking a train ticket on the Indian Railways website. You put in your journey. That's your input. You expect one single price to come out, right? That's your output. Imagine if the system gave you 2 different prices for the exact same ticket. It would be total chaos. That system has to be a function to work. Visually, this rule is a really simple test. Look on the left. Every input has exactly 1 arrow coming out of it. Predictable, reliable. That's a function. Now look on the right. See that first input? It has 2 arrows. The rule is broken. That is not a function. It's that simple. So now that we know the rule, let's see how these ideas actually look. Because when you put them on a graph, functions show up as these beautiful visual patterns, each with its own unique personality. First up, you've got the identity function. We can call this one the mirror. It's super simple. Whatever you put in, you get the exact same thing out. It creates this perfect, clean 45-degree line. Then you have the constant function, or as I like to call it, the flat line. It literally does not matter what input you give it, the output is always the same. Rock steady. A perfect horizontal line. And one of my personal favorites, the modulus function, or the rebound. This one is cool. It takes any number, negative or positive, and only gives you back the positive version. It creates this sharp V shape, like it hit 0 and just bounces right back up. Once you learn to speak this language, you start seeing these patterns absolutely everywhere, from the orbit of the planets to the price of your morning chai. So I'll leave you with this thought. Now that you know the code, what parts of your world are just functions in disguise?